this question, we're asked to sketch the area bounded by these two equations and revolve it around the y-axis. We're asked to find the volume of the solid formed by the revolution. A calculator is allowed, so we have a calculator here, and so we want to round to 3 decimal places. So the functions we have are y equals x squared and y equals 2x. But one thing I see is that we're going to revolve around the y-axis. And so we're going to want to rewrite both of these equations in terms of y instead of in terms of x. So this one, y equals x squared, I'll square root both sides, and so I'll get the positive or negative square root of y equals x. And then here we'll get, divide by 2 on both sides, we'll get y over 2 equals x. Just so we have those equations so we know what we're looking at. The next thing that we're going to want to do is we're going to want to draw this out just to know what situation is happening. So I'm going to do that here. Y equals x squared, that parabola looks like this. And y equals 2x is going to be a line that goes something like that. And so what we'll see here is that this area I'm about to color in, this is the area we care about. And so we want to think about, well, when are those going to be equal to each other? Well, we can set, when are the y's going to equal each other is what we want to know, and so we want to set both of these equal to each other. But before we do that, for this first equation, we need to see, well, is it going to be positive or negative? Well, we see that we're on the right side, so we're looking at the positive values for y, and also the positive values for x. And so we can just say, instead of plus or minus, it's just square root of y equals x. I can write that next to, not square root of x, square root of y, square root of y, and then this one was y over 2. All right, and when are those equal to each other? Well, let's set them equal to each other. The square root of y equals y over 2. I'm going to square both sides. So we'll get y equals y squared over 4. I'll multiply 4 on both sides. 4y equals y squared. Y squared minus 4y equals 0, and we can factor this. And this will tell us that our two bounds, our two y values, are going to be 0 is y, and also, not 0 there, 4 is y. Okay, so we know the bounds. We know that this y value right here, well, we already can see that, but this y value right here is 0, and this y value where they meet will be 4. Why is that important? Well, we need the bounds for where we're revolving around. And so it says we're going around the y-axis. So I'm going to draw a little thing there to show that we're revolving around the y-axis. And so whenever we're trying to figure these out, we want to say, what is the volume of the outer shell or the outer circle? And that comes from the function that's all the way on the outside. And I'll use red to denote this. We're going all the way on the outside here. That function that's all the way on the outside, that's our square root of y function. And so we want to see if we revolve that around the x-axis, we're going to be making circles. So I'm going to write out that integral that's going to represent that. Well, we're going from 0 to 4. The function is square root of y. So that square root of y gives us our radius. But since we're making a circle, we take our radius and we square it. And then we multiply it by pi, because pi r squared is the area of a circle. But we're integrating not just one circle, but all of the circles from 0 to 4 in order to find a volume, which is why we put that dy, because that gives us the thickness for the volume. So this red tells us the outer portion. But what about the inner portion? I'll do this one in yellow. The inner portion, we can see if we start from the y-axis and go right here, that line is our y over 2. And so we take our outside shell and we want to erase what's on the inside. So we're going to subtract the integral again from 0 to 4. Since we're finding circles, we do pi times r squared. The radius this time is y over 2 squared dy. We can simplify this just a little bit, and I'm going to go back to blue to show that this is just one answer. We can say the integral from 0 to 4, I can take out my pi. Square root of y squared is just going to be y dy, minus, again, pi, the integral from 0 to 4 of y squared over 4 dy. I'm going to simplify this one more time just to put it all together. I can see that I can combine these two, and so I'm going to get pi integral from 0 to 4 of y minus y squared over 4 dy. This will tell us the volume of the solid that's made when we rotate this little sliver. I'll come back around and show it. This blue part around the x-axis, just like, or around the y-axis, sorry. It'll make some solid like that. So let's calculate that out. Remember, that's math 9. Our bounds are from 0. Ooh, I forgot one thing. I want pi here. So I want second pi, math 9, from 0 to 4 of y, or we can just do x because it doesn't know the difference here, x minus, and I want my fraction, so alpha x squared over 4. And we hit enter, that gives us our final response. And I like to round, but you can truncate it, so either 8.377 or 8.378. And that is our volume of the solid.